Hello everyone, welcome to Smart Interviews YouTube channel, your one-stop solution to ace tech interviews. In this video, we'll be discussing latest Codechef contest, Starters 193, Div.4, first 4 problems. So without any delay, let us begin.
Let's start with the first problem. First, let's read the problem statement, then find a solution, then let's convert the solution to the code. The problem statement is rectangle and square. You have a rectangle of length A units and breadth B units. You also have a square with side length of C units. Check if both rectangle and square have same area. Print S if they have same area and no otherwise. The first and only line of input contains three integers A, B and C. So in the inputs we are given three integers A, B and C. Now what does this A and B represents? The length and the breadth of the rectangle. What does C represents? The side of the square. Now the problem asks us to check whether the area of rectangle is same as area of square. Now how do you find the area of rectangle? It's simply A into B, which is nothing but length into breadth. Now how do you find the area of square, which is nothing but C into C or C square, which is nothing but side square. Now how do we compare them? I can simply check whether the area of rectangle is same as area of square. If they're same, what should I do? Print S. Otherwise, print no. That's it. With just an if-else condition, we can find the solution for this problem. Let's go ahead and code it up. Alright, let's code it up. We know that we are given only three integers A, B and C. So let's take the input of them. I also need to worry about the data types because the values of numbers are pretty low, so I can int is enough. So what's the next thing? I have to compare. So how do I find the area of rectangle? So it's simply A into B and check whether if it is equals to C into C. If they are same, what should I do? Simply print S. Otherwise, print no. Let's run the code. So the sample test case have passed. Let's submit it. That's it. Let's start with the second problem. Count odd even divisors. You have an integer n. You want to calculate the number of odd divisors of n and the number of even divisors of n. For example, 2 has one odd divisor and one even divisor. Similarly, 8 has one odd divisor and 3 even divisors. So what does the problem says? You're given an integer, let's say n. Let's take an example. Let's say n is 8 and we have to simplify the total number of odd divisors. We have to find the total number of odd divisors and the total number of even divisors. Now, what is a divisor? Now, a divisor is a number which divides the n completely. That is, the remainder should be 0. Only then I can say a number is a divisor of n. Let's take an example. Let's say 2. Can 2 divide 8 completely? Yes. So 2 divides 8, 4 is 8, you'll get a remainder as 0. So clear with the divisor? Now I have to find the total number of odd divisors and even divisors of n. Now first thing, how do I find a divisor? I know that x is a divisor of n if n mod x is 0. So first thing, x should divide the n completely. Then if x is a divisor, then I have to find the parity of the x. That is, if it is odd or even. If it is odd, increase the count. If it is even, increase the count. So clear? Let's try to convert the same thing into the code. Now, what all things are we given? We are given only integer n. So we'll take the input. So we'll read n. First let's initialize n. And we have to find both odd and even count. So let's take the variables. let's say even count initialize to 0 and the odd count initialize to 0. Now I need to find the valid divisors. Can the divisors of n exceed greater than n? If n was 100, can I have a divisor greater than 100? No, right? So that means all the divisors will be in the range of 1 to 100, both inclusive. So for that, what can I do? I can simply run a for loop, say initialize I with 1 and run the for loop till 100. In our case, it's the variable n I plus plus. Now what should I do? Simply check if the I is a divisor or not. So what can I do? I will simply do n mod I. If it's equals to 0, then what should I do? Now I have to check the parity of the I. If I mod 2 is equal to 0, what does I mod 2 give us? If it is equal to 0, it says it's an even. So I'll simply increase the count of even, otherwise increase the count of odd. At the end, what can I do? Simply print both odd, even. Let's convert the same thing to the code. Alright, let's go to the second problem. Let's look at the input formats. You're given t, the number of test cases, and in each test case you're given a single integer n, to which we have to find number of odd and even divisors. And in the output format, we have to simply print the number of odd divisors followed by number of even divisors. Let's go ahead and code it up. Int first t, which is nothing but the number of test cases. Now for each test case, you are given a single integer n, so let's take the input of n as well. Now what you have to do? You have to find the odd and even divisors. So let's maintain two variables to maintain the count of odd and even divisors. Now we know that the range of divisors goes from 1 to n, both inclusive. So let's run a loop from 1 to n and check if the current number is divisor of n. How do I do it? If n mod I is equals to 0, that means it is a divisor. Now I have to segregate it, check whether it's odd or even. How do I check it? Simply, if I mod 2 is equals to 0, that means it's an even, otherwise it's an odd. Now what should I print? First, print the odd divisors, space, even, and print a new line. Let's run the code. Let's look at sample input and output. The sample outputs are matching. Let's submit it. It got submitted. Let's move to the next problem. Let's discuss the third problem. I want you guys to go through the problem statement. I will provide the problem link in the description. Alright, let's discuss the problem. So in the input, you're given a and b, which are integers. You have to simply check if there exists a positive integer n such that it has exactly a odd divisors and b even divisors. Now in the previous problem, we are given n. In the input, we have to simply find a and b. What are these a and b? A is number of odd divisors of n and b is number of even divisors of n. Now in the problem statement, in the current problem statement, we are given a and b. We have to simply check if there exists an n which satisfies the condition of a and b. Let's take an example. So 2 has one odd divisor and one even divisor. Similarly, 8 has one odd divisor and 3 even divisors. So in the input, if a and b are 1 and 1, that means we have to check if there exists a number n which has exactly a number of odd divisors and b number of even divisors. Of course, 2 has one odd divisor which is 1 and one even divisor which is 2. Similarly, if in the input we are given 1 and 3, we have to simply check if there exists a n which has one odd divisor and 3 even divisors. An example, 1 and the 3 divisors are 2, 4 and 8, which is a number 8. So we have to simply print yes in these cases, and if the condition does not satisfy, we have to simply print no. So that's the entire problem statement. Now let's go and check the sample inputs and outputs. Now in the first test case, we are given a as 1 and b as 0. So any number which satisfies the condition. We have n as 1, which has 1 as only one divisor, which is odd, and it has 0 even divisor. So its output should be true, which is S. Now in the second test case, A is given as 0. Now any positive integer will definitely have 1 as divisor. So that means my A can never be 0. So first observation, let's note it down. First observation is A should be greater than 0. A cannot be 0. In this case, we can simply print no, because we know that every positive integer has at least one divisor, which is 1, which is an odd. So A can never be 0. In the second test case, which was already discussed for 2 and 8, so true and true, we will see why 3, 2 is false. Now, we are given A and B. We have to simply check if there exists an n. Let's go in the opposite direction. Let's take an n. Let's say we're having an n. Now, how can I represent this n in prime factorization? You can simply say P1 A1 into P2 A2 into P3 A3 and so on. Now, what are these P1, P2, P3? All these P1, P2, P3 are prime numbers. And other thing is P1 is less than P2 is less than P3, and all these are primes. Now, what is the first? What can P1 be? P1 can be 2, 3, 5 and so on. Now, in the input we are given A and B, where B represents some number of even prime numbers. Now, if a number has even prime numbers, that means my P1 should be greater than 0. Because 2 is the only prime number which is even. So, if you want some even number of divisors, that means my P1 should be definitely be greater than 0. An example could be simply 20. How can I print 20 in prime factorization? 2 power 2 into 5 power 1. So do you see, if a number has some number of divisors which are even. Now let's also write the divisors of 20. 1, 2, 4, 5, 10 and 20. Do you see it has some number of even prime numbers? Sorry, even divisors. So if a number has some number of even divisors, that means the P1, which is power of 2, should be greater than 0. We can also take another number. Let's say 21. Now prime factorization of 21 is 3 into 7. Powers are 1. Prime. What are the divisors? 1, 3, 7 and 21. Now do you see all of them are odd divisors? So if a number has powers of 2, if the power of 2 is 0, that means it doesn't have any even divisors. Now similarly, if my if my A1 is 0, that means do I have any even prime numbers? Sorry, do I have any even divisors? No, that means A1 should be greater than 0. First thing. And second observation. Let's write. Let's take a number. Let's say x, which is a divisor of n. Now, how do I represent this x1 in prime factorization? Let's say P1 B1 into P2 B2 into P3 B3 and so on. Now, in order for the x to be a divisor of n, what is the condition? When x divides the n, the remainder should be 0. So that means P1 A1 into P2 A2 into P3 A3 and so on divides P1 B1 into P2 B2 into P3 B3 and so on. Now, in order to x be a divisor of n, what should be the condition? B1 should be less than or equals to A1 and B2 should be less than or equals to A2 and so on. That means BI should be less than or equals to AI. AI should always be greater than BI. So if I do that division, what will be the output? It will be something like P1 A1 minus B1 into P2 A2 minus B2 into P3 A3 minus B3 and so on. Now, if a number If a number should have even number of divisors, that means a1 should be greater than 0 and p1 should not be equals to 1. It should be greater than 1. Only then it can have even number of divisors. Another observation. Now let's say we are having a divisor x which is completely odd. Let's say x is odd. If x is odd, what is the prime factorization of x? X is no longer going to have p1 because we know that an odd number will never have p1, which is missing. So it will start from p2. So let's say x equals to p2 b2 into p2 b3 into p3, okay, p3 b3 p4 b4 and so on. Now let's say x is a divisor of n. So important point, if x is odd and it's a divisor of n, there exists y number of even divisors for every odd divisor of n. Let's see why. Let's take an example. Let's say n is 100. Now how can we represent this 100 in prime factorization? 2 power 2 into 5 power 2. Now what is the problem? What does the statement says? It says that for every odd divisor there exists y number of even divisors only if n is even. If n is odd, you are not going to have any even divisors. So if n is even, that means for every odd divisor you are going to have some number of even divisors. Let's see why. Now for 100, let's list down all the divisors. So 1, 2, 4, then 5, then 20, then 40, then 100. I hope I did not miss any divisors. So let's segregate them. Odd will be 1, 5. Okay, we did miss 25 as well. So 25, then 50, then 100. So odd divisors are 1, 25, and 5 and 25. Even are 2, 4, 20, 50 and 100. Now let's take the first odd divisor. And before that, let's validate this thing. There exists a y number of even divisors for every odd divisor. Now, let's say x is an odd divisor. If x is an odd divisor, that means, can I say 2 into x is a divisor of n? Yes, because 2 into x will be an even and it's an even divisor which can divide n. Similarly, 2 power 2 into x, 2 power 3 into x, so on till 2 power k into x can be divisors of n. Let's see the limit. These are nothing but, let's say, y number of even divisors of odd divisor of n. Again, the condition is n should always be even. Now let's see. Now let's take the first odd divisor, which is 1. Now for 1, how many even divisors can it generate? Let's see. So 1 into 2 power 0, can I do that? So which is 2. 2 is an even divisor, which satisfies the condition. Then 1 into 2 power 1. Sorry, this is 2 power 0, which is 1. So let's start from 1. Let's ignore this. So let's start again. 1 into 2 power 1, which is 2, which is an even divisor. Then 1 into 2 power 2, which is 4, which is an even divisor. Now, can I have 1 into 2 power 3, which is 8? No, right? If you see, in my prime factorization, my A1 is only 2. So that means I can only generate 2 even divisors for every odd divisor. So now what is the value of y? Now y is a1, it's not y. Let's continue tracing down. Let's continue to find the value for 5 as well. Now for the 5, how many can we generate? How many even can we generate? So 5 into 2 power 1, 5 into 2 power 2. 5 into 2 power 1 is 10. Okay, we also missed the 10 as well. Let me write the 10. So that means 10 is also an even divisor. So we have 10 and we have 2 power 2, 4, 5 was 20. So 10, 20 as well done. Now what's the third odd divisor, which is 25. So for 25, we can simply say 25 into 2 power 1, 25 into 2 power 2, which are 50 and 100. Both are even. So that means for every odd divisor, let me rewrite the statement. For every odd divisor of n, there exists a1 number of even divisors. So this condition satisfies. This is true only if n has even divisors. That means a1 should be greater than 0. So can I say number of even divisors is nothing but number of odd divisors into a1, where a1 is the power of 2. We have just seen by a1. Now a1 is nothing but 2. So p1 is 2, a1 is 2, p2 is 5, a2 is 5. Now this is p3, we can also say p2, it's totally fine. So clear? Now that means, can I say number of even divisors is nothing but number of odd divisors into a1, where a1 is the power of 2. So how can I rewrite this? Can I simply say, let's say even divisors are b, odd divisors are a. That means b should be equals to a into a1. How can I rewrite this? So that means b by a should be a1 and a1 should be greater than 0, or we can simply say b mod a should be equals to 0. Only then the condition satisfies. Only then we can have a and b as valid to get a number n. So let's write the conditions. So in the first observation, we found that if a is 0, we can simply print no. So let's write the first condition. If a is 0, print no. Second observation, now we know that an odd number will only have all the odd divisors. So that means it can have b as 0 and a can be greater than 0. Then we can simply print true. This will satisfy all the odd cases, odd numbers n. So that means we can also have b as 0. So another case is if b is 0 and if a, and we no need to write a greater than 0, because if a is 0, it will be handled here itself. So let's write an else condition. Else if b equals to 0, we can print s. Third condition was b mod a should be equals to 0. So another condition, else if b mod a If it's equals to 0, we can print S. So in the other cases, simply print no, because we know that only these are the valid cases, the rest of the invalid. Now coming back to the example. Now here A is 3 and B is 2. Now let's check the condition. First condition fails where A is not equal to 0. Second condition is B equal to 0, even B is not equal to 0. The third condition is B mod A should be equal to 0. So is A multiple of B? So what is B? B's number of even divisors should be multiple of odd divisors. Is 2 multiple of 3? No. So that means the output should be false, which is no. Let's go ahead and convert the same logic to code. Alright, let's go to the third problem. We have already gone through the problem statement. Let's look at the input format. You are given T, number of test cases, and in each test case you are given two integers A and B. So let's take the inputs. So input of T is done, which has nothing but the number of test cases. So let's write a loop for test cases. Then let's take the inputs of A and B. Now the conditions. First condition is if A is 0, print no, else. Other condition is if B is 0, you can straight away print yes, because we know that every odd number will have 0 number of even divisors and B number of odd divisors. So you can simply print yes. Now the other condition where A and B are both not equals to 0. We found the reason, we also validated it. So B mod A is equals to 0. You have to simply print yes. The rest of the cases are false. So else CO no and new line. Let's run the code. Let's look at the sample input and output. Yes, no, yes, yes, no. Let's submit it. It got submitted successfully. Let's solve the fourth problem, adding permutations. You're given a one-based permutation in the range of 1 to n. We'll have to construct an array A of size n, where A of I equals to P of I plus I. Let F of P be a as the number of distinct elements in our array A. So let's take the example. Let's try to consider the same example. Let's say the permutation P is 3, 4, 1 and 2. Now how can I generate A? Since it is a one-based indexing, I have to add 1 here, I have to add 2 here, I have to add 3 here, and I have to add 4 here. This becomes 4, this becomes 6, this becomes 4, and this becomes 6. So what is the value of F of A? 2, because we only have 2 distinct elements. These are repeating elements. So do you understand what F of A represents? So F of A represents the number of distinct elements in the generated A. How can I generate the A? We generate the A from P by adding plus 1 at the index 0, plus 2 at the index 1, plus 3 at the index 2, and plus 4 at the index and so on. So since it's a one-based indexing, we start with 1. Now in the input we are given n and k. We have to find a permutation P of the integers in the range of 1 to n such that F of P equals to k. It also says that answers will always be existed. Okay, fine. Now clear the problem statement. The problem statement says that now in the input we are given just n and k, where n is the size of the permutation and k is the number of distinct elements in A. Now we have to find a permutation P such that it satisfies this condition where F of A equals to k. Now let's say I give you k as 1 and n as 5. Let's say n is 5 and k is 1. So what is the permutation? One of the permutation for n as 5 is, can I say 1, 2, 3, 4, 5. A will be, so 1 plus 1, 2, then 3, 4, 5 and 6. How many distinct elements? So F of A is equals to 5. But what is our motive? Our motive is to have only one distinct elements. So What should I do to get one distinct elements? All the elements in A should be similar, should be same. So what can I do? One of the possible permutation could be simply take the descending order, that is 5, 4, 3, 2 and 1. Now if I do the same thing, if I construct A, it will be, we'll add 1, we'll add 2, we'll add 3, we'll add 4, we'll add 5. So we'll add 1, 2, 3, 4 and 5. What is the generated A? 6, 6, 6, 6 and 6. Now do you see f of A is only 1? We thought k as 1, right? Now what if my k is 2? What kind of permutation satisfies k as 2? N is 5, k is 2. Now if k is 2, that means, do you understand that some of the elements, let's say 4 elements, should be equals to k, equals to 1 element, and the rest of the element should be another element? Now how do you satisfy this condition? Now what did you observe here? If you see, when I took that reverse order, the descending order of the entire n, I was able to generate one element in all the values of A. If I have to generate one element in 4 values, what should I do? Another way can be, let's say I only have 2 elements. If I had to make these 2 elements same, what can I do? I'll add plus 2, I'll add plus 1. So both these values will become same, right? This will be 3, this will also be 3. Similarly, let's say I have to make 3 elements same. So what can I do? I'll add plus 3, plus 2, plus 1. Now, do you see? I can only add elements, I can only add values in this range, in this order, 1, 2, 3 and so on. So that means this element should be in reverse order. That is 3, 2, 1 and 4, 5. If I write it this way, I need to add plus 1 here, plus 2, then plus 3 here, plus 4, and then plus 5 here. Now, if I had to construct A, the A will be simply 4, 4, 4, 8 and 10. Do you see? 3 elements are same and we have 2 different elements, so the value of k will be 3. Similarly, if I need just k as 2, okay, we were discussing that about k as 2, right? So that means what should I do? I have to somehow make first 4 elements as same. So what should I do to make first 4 elements as same? I can simply reverse the first 4 elements and add plus 4 here, plus 3 here, plus 2 here, plus 1 here. All these elements will become 5. So what should I do? What kind of permutation should I take? You can simply take 4, 3, 2, 1 and 5. Then add plus 1, plus 2, plus 3, plus 4 and plus 5. All these elements will be 5, 5, 5, 5 and 6. So do you see only 2 unique elements are there? For the 3, you can simply take this kind of permutation. So what do you observe here? Do you see a pattern here? If I need only one valid k, I will reverse the entire permutation, entire valid permutation from 1 to n. If I need two unique elements, what should I do? I need to reverse from 1 to n minus 1 and leave n as the same. So I'll get k as 2. Next, if I need 3, I'll do 1 to n minus 2 elements. I'll reverse the 1 to n minus elements and then leave n minus 1 to n elements as it is. So I'll get k as 3. So same thing I can go and continue. We can take the examples from the sample itself. So for this example, n as 1, k as 1. What can I do? N is 1. So k as 1. So one possible combination is just add 1 to it. You'll get 2. So a will become 2, which is only one unique element. So what is the array? You can simply take 1 as the array. For the second example, you have n as 2, k as 1. So if n is 2, that means you'll have 1 and 2. You want k as 1. That means you only need one unique element. What will you do? Reverse this. You'll do 2, 1. You'll add plus 1. You'll add plus 2. You'll get 3 and 3. The array will be 3 and 3. So which permutation did you take? We took this permutation. So 2 and 1. Similarly, if I had to do 2, 2. So one of the permutation was 1, 2. Then second permutation was 2, 1. If I take this permutation, how many unique values will I get? So 1 plus 1 plus 2, I'll get 2 and 3. So this is one of the permutation which has 2 values, k as 2. So another valid permutation. Similarly, let's solve. You can also find out for 4, 2. Let's solve for 6 and 3. So 6 and 3. n equals to 6, k equals to 3. So n equals 6. Let's write the first permutation. First valid permutation is 1, 2, 3, 4, 5 and 6. Now, how many unique elements do I need? I need 3. So that means I need to divide the array into 2 parts. From where to where should I divide? I need 2 unique elements. That means I'll simply partition the array here. So I'll get two unique elements here, and I have to somehow make all these elements as a single unique element. So what should I do? I'll simply reverse this array. So this will become 4, 3, 2, 1, and 5 and 6 remain same. Now what's the next step? Generate the array. What will I do? Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. If you find it, you'll have 5s here, you'll have 10 here, you'll have 12 here. So do you see we got 3 unique elements? 1, 2, and 3. So do you see this pattern will work for all the examples? I mean, in the problem, it stated that you can print any one of the possibility. So this is one of the possible answer, right? So do you see this pattern can be used for every answer? But how do I know that I need to partition here? I mean, when I say partition, not exactly partition, I just somehow need to find this value. How will I find it? We know when k is 3, I have to make some of the elements as one element and the remaining to be another element. So that means I need k minus 1 elements on my right side and one element to be same on the left side. So out of n, I need 2 unique values. So when k was 3, I need 2 unique values. So what can I do? N minus k minus 1. So which will be n minus k plus 1. So that means I have to reverse n minus k plus 1 elements. You can take the example. N was 6. 6 minus 3 plus 1 will give me 4. So do you see the first 4 elements need to be reversed? And we reversed them. So how do I find the answer? So we can simply have an answer array initialized to size 6, 0, 1, 2. So let's say these are the indexes for n as 6 and k as 3. Now I'll find the value. Let's say value equals to n minus k plus 1, which is 4. So that means I'll simply run a loop from I equals to 0 to 4 exclusive, and this is inclusive. So what I'll do? Answer of I equals to value, and I will decrease the value. That's it. This will take care of filling the array with 4, 3, 2, 1. Now what do you need here? From here I need to start filling from 5 and 6. So what can I do? I can again initialize the value to n minus k plus 1 plus 1. So this will become 5. So I'll initialize 5 here, then I'll initialize 6 here. So let's try to convert the same logic into the code. Let's code the fourth problem. Add permutations. We already read the problem description. Let's look at the input format. You're given t number of test cases, and in each test case you're given n and k. You have to print the output. We know what is our output. So let's take the inputs. So in t, the number of test cases. Now run a while loop for the number of test cases. And if for each test case we are having 2 values, n comma k. Let's take the inputs. Now what is the answer array? Answer array is of size n. So let me initialize everything to 0. Now what should I do? Find the first value. What is the value? Value equals to n minus k plus 1. So let me store in a temp so that I can use them. Now run a loop. Int I equals 0, I less than 10, I plus plus. So answer of I equals to val minus minus. This will take care of filling the first x elements, let's say value elements. Once we're done, what should I do? Next initialize the value again. Value equals to 10 plus 1. Next run the for loop. Now once we're done with filling first 4 elements, that is 4, 3, 2, 1. Now what should I do? I should start filling my permutation with 5 and 6. Now I know my value is, my temp is pointing to 4. So again reinitialize the value to 5 and start filling the array. From where should I fill the array? From the temp. And go till n. And we can simply say answer of I equals to val plus plus. And what should I do? What's the last step? Print the permutation. And I equal to 0, I less than n, I plus plus. See what answer of 5. Let's give a space, then new line. Once you're done with the printing array, let's print a new line. Let me check for the comparison errors. Test cases input. For each test case, we get n and k. Take the inputs, initialize the answer array of size n, then take the value which is n minus k plus 1, store it in a time, run a loop for 10 times, then update the answer array for the first values, then again initialize the value with 10 plus 1, run the loop from I equals to 10, I less than n, I plus plus, answer of I equals to value plus plus, and print the answer. Let's run it. Let's see if we get the expected output or not. So first 4 elements, when k was 3 and n was 6, we need to revert the first 4 elements, 1, 4, 3, 2, 1, then 5, 6. Let's submit it. It got submitted. I hope you understood the logic. First we initialize the first k values, we reverse the order and initialize them. Then once we are done, then the k minus elements should be ordered from value, right? So what did I do? I reinitialized the value to 10 plus 1 and started incrementing the values after each iteration and printing the array.
That's it for this video. Thank you for watching. If you like the video, make sure you like, share, subscribe to 𝗟𝗲𝗃𝗲𝗃𝗃 YouTube channel. See you in the next video.